All right, ladies and gentlemen, so today we're going to be taking a look at how we can graph these functions. All right, so we know a function has to have no repeats in our x values. You have to pass the vertical line test, all that good stuff. So characteristics, we have a bunch of different kinds of functions. We're going to start with linear. Linear means that it forms a straight line. We dealt with linear functions last year when we graphed our proportional and non-proportional relationships. Those were linear functions. And the highest exponent is a 1, and any of your variables. All right, so for example, the first one here, we're going to start off with our vertical and horizontal lines. So we have f of x equals 5, which means y equals 5. Which means if I make a table, it doesn't matter, of course this isn't going to work, it doesn't matter what x is, y is always going to be 5, right? So I'm just going to fill in some numbers here, -2, -1, 0, 1, 2. These are going to look like horizontal lines. And we always want to make sure that we label these. So y equals 5 or f of x equals 5. Okay, next one. Okay, so x equals 5. This one cannot be graphed on a calculator because it's technically not a function. We can show what it looks like, but it's not going to come up on a calculator. Because no matter what x is, no matter what y is, x is always 5. So these are going to be your vertical lines that go straight up and down, and of course we want to label it, right? But that was not a function. All right, so let's see if we can do number 3 here. So here I have f of x equals 3x, and what I'm going to do is I'm going to pick some values to put in. The most common values that we pick are -2, -1, 0, 1, and 2. And instead of making you show the work here, I'm just letting you do a table. So this means to get y, I have to do, of course I reversed that. I have to do -2 times 3. Well, -2 times 3 is -6. -1 times 3 is -3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. So when I graph it, we're going to have -2, -6. -1, -3, 0, 0, 1, 3, and 2, 6. And you should always use a straight edge, whether it's the edge of a binder or an actual ruler. And of course, we want to label this f of x equals 3x. All right, hopefully not so hard. All right, so those are linear functions, straight lines. We're also today going to talk about something called a quadratic function. Quadratic functions form a U. They have an exponent of 2, which means that we're going to have an x squared somewhere in here. And it's also called a parabola. Of course, I have to make sure that I spell that right. Okay, so when all you have is the plane function, that's called a parent function, right? Parent function is going to be kind of your plane. It's your most basic one that you can get. No other extra coefficients or constants are added in. It's your plane function. So when I take a look at this, again, I'm going to do my -2, -1, 0, 1, 2. So now I'm going to square those. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Notice over here we now have some repeats in our y values, and that's going to happen in a parabola. So let's take a look at what this is going to look like. So we're going to have -2, 4, -1, 1, 0, 0. Okay, so we get this nice continuous U shape. All right, and then This is called, excuse me, so we're going to label it f of x equals x squared. All right, this is this little point down here. It has a couple of names. This is called the turning point. It's also called the vertex, and those are going to be some words that we're going to keep using throughout the rest of the chapter and the rest of the year. Okay, it's the turning point, it's the vertex. Okay, it's also where it meets the x-axis, it's also called a zero. Not because it's at zero, but because, and we'll talk a little bit more about that in our next example. All right, so let's try the next one. So now, all right, sorry about that. So now we're going to have a different type of quadratic function. It's still a quadratic because it has the x squared. So I'm going to start with my values again, -2, -1, 0, 1, 2. This means that I have to square it, make it negative, and then add 4. Right? So I'm going to use this space over here to help me. So this is going to be the negative of -2 squared plus 4. All right, well, let's think about that. -2 squared is 4. I'm going to make it negative. 4 plus 4, -4 plus 4 is 0. All right, so here I'm going to have -1 squared plus 4. Well, -1 squared is 1, so that's -1 plus 4 is 3. This is going to be a 4 because 0 doesn't do anything. And then this is where they should start repeating themselves. So this is the negative of 1 squared plus 4, which is still -1 plus 4, 3. And then this one's going to be your 0. So this time we're going to have, so we're at 0, 4. We had -2, 0, -1, oops. -1, 3, 1, 3, 2, 0. So this time it's going in the opposite direction. And that's because the coefficient in front of your x squared term was a negative. So here again is your, I have to label it, sorry. So f of x equals -x squared plus 4. Here's your vertex or turning point, right? Where it crosses the x-axes are called zeros, right? So these are zeros. They're also called solutions, and we're going to definitely be talking a heck of a lot more about that later. All right, they're zeros, they're solutions, they're also called roots. Those all mean the exact same thing. And again, we'll get more with that a little bit later. All right, it's about filling in a chart and being able to put the values in. You pick values for your inputs instead of them giving them to you, and then you figure out the outputs and graph it. All right, any questions? Bring them to class. Have a good night.